Okay, in this lecture, we will see gears introduction, classification, terminology, nomenclature, and various types of gear tooth systems. First of all, we will see about the mechanical drives. Belt drive, chain drives, and gear drives are often called as mechanical drives, and these drives are generally used for transferring the mechanical power over a certain distance for changing the speed and torque of the machine. Okay, generally these drives are used between one component such as prime mover, we will generally call it as an electric motor, and another operating machine for changing the speed of the machines or torque of the machines. And the examples involved where these drives are generally used, it includes traveling crane, lathe machine, shaper, and planer. In all these machines, generally mechanical drives are widely used. And coming to the classification of mechanical drives, these are generally classified based upon the transmission of power by means of friction. The examples are belt drives and the rope drives, which transmit the power by means of friction, and transmission of power by means of engagement. Generally, the chain drives and gear drives comes under the category of transmission of power by engagement. And in this lecture, we will generally concentrate on the gear drives, which transmit the power from one shaft to the another shaft by successive engagement of the teeth. The main advantages of the gear drives, which includes it is a positive drive and the velocity ratio is also constant, and the center distance between the shafts is relatively small, and which results in compact construction, and it can transmit very large power which is beyond the range of belt and chain drives. And in belt drives and chain drives, generally we will have low power transmission capacity due to various disadvantages, and it can transmit, gear drives can transmit motion at very low velocity which is beyond the range of belt drives, and the efficiency of the gear drive is very high. We can achieve efficiency of the order of 99% in case of spur gears, and a provision can be made in the gearbox for gear shifting for changing the velocity ratio over a wide range. And the main disadvantages of the gear drives includes it requires lubrication, and also the costlier gear drives are costly and their maintenance cost is also higher, and it requires sophisticated persons and sophisticated equipment for manufacturing these drives. Therefore, the manufacturing process is somewhat complicated and it requires highly specialized. And the lubrication and cleanliness is also one of the disadvantages in case of a gear drive. Now coming to the classification of gears, the gear drives are generally classified as spur gears. This is the first classification, where you can see here you have a pinion and a gear, and the power is being transmitted from the pinion to the gear. And here you can observe the teeth are cut parallel to the axis of the shaft, and the profile of the gear tooth is in the shape of the involute. And during this power transmission, you can clearly observe the spur gear drives impose the radial loads. And the second classification includes helical gear, where the teeth are cut inclined to the axis of the shaft, and you can clearly see from this figure how the teeth are cut in pinion and gear drives, and these are cut inclined to the axis of the shaft, and the shape of the involute, shape of the gear tooth is in the shape of involute profile curve, and the helical gears impose radial loads and thrust loads. Okay, this is the sub-classification of an helical gear, where you will have both right hand teeth as well as left hand teeth in a single gear. We'll call it as a herringbone gear. You can see this construction. These are generally used for transferring the precise motion in case of industries, for transferring with higher speeds. If you wanted to transfer, then we can use herringbone gears. And this is the another gear. Third gear is a bevel gear. You can see the construction, and you can see the side view of the figure, where we are having the straight teeth of bevel gear, where the teeth are straight, and here you can see another figure where you are having the spiral teeth of bevel gear. And these bevel gears are used for transferring the power, which are at the shafts are placed at right angles to each other, and the tooths of the bevel gear are made straight or spiral depending upon the application. The teeth are cut straight or spiral. And the last classification includes worm gear drive, where you will have two types of gears. One is worm and another one is the worm wheel. The worm is in the form of a threaded screw, and it matches with the threads of the worm matches with the threads cut on the worm wheel. And depending upon the efficiency and depending upon the power requirement, we are having different types of starts: single start worm, double start, triple start, and so on. And this is the nomenclature of a worm gear drive. And these drives are used generally in high speed reduction purpose in case of material handling equipments. And in this case, the worm imposes the thrust load because it is moving in the sliding motion, where the power is being transmitted to the worm wheel, and the worm wheel imposes here the radial loads on the shafts. And these drives are generally used for high speed reduction ratio purpose. If you wanted to achieve speed reduction of 100:1 or 200:1, then generally worm gear drives are used. And this table gives an overall view of selecting which type of gear is used for what purpose. And generally the selection of gear mainly done based on output layout of the shaft, okay, speed reduction, and the power to be transmitted, the input speed, and the cost of manufacturing. And you can see clearly here the spur gear, helical gear, bevel gear, and worm gear. Depending upon the speed ratios and depending upon the generation of noise and a manufacturing facility, we need to select a proper gear drive for a particular application. Suppose if you wanted to achieve high speed reduction ratio, then we need to go for the worm gear drive. We are achieving here 60:1 to 100:1, and in some cases we can achieve up to 200:1. In case of spur gears, the speed reduction is 6:1 to 10:1. And here spur gears will generate higher noise. If you wanted to require lower noise, then we need to select helical gear, moderate noise, bevel gear. And worm gear drives are not used generally for transmitting higher power. If you wanted to transmit lower power, then generally we will select worm gear drive. And depending upon the manufacturing cost, the manufacturing cost of spur gear is simple, and manufacturing cost of helical gear is somewhat specialized and high cost. And similarly bevel gear also high cost, and in case of worm gears it is also costlier. The worm wheel is generally made up of phosphor bronze, and it is somewhat costlier compared to the worm. Therefore, depending upon the input speed, cost, manufacturing facility, and the power to be transmitted, speed reduction ratios, the velocity ratios to be maintained, we need to select a proper drive for a required application. And these are the terminologies related to a spur gear. Okay, from this figure you can clearly see various terminology of a spur gear. That is the center line, it is called as a pitch circle, and the top line touching the tooth surface, it is addendum circle, and the bottom of the tooth surface we'll call it as a dedendum circle, and from pitch circle to the top of the tooth we'll call it as addendum, and pitch circle to the bottom of the tooth dedendum, and the working depth, hole depth, face width of the gear, face of the gear, flank of the gear, bottom land, fillet radius, and the clearance to be maintained. It is clearly observed from this figure what are the nomenclatures for a spur gear. And in this figure you can see here I have considered pinion as well as the gear. Okay, the power is being transmitted from the pinion to the gear, and from the center of the pinion to the center of the gear we'll call the center distance, and also the pitch circle diameters of pinion, pitch circle diameters of the gear, and during the engagement the teeth profile, and also where the pressure angle is maintained. It is clearly seen from the side view of the figure, and based upon these two figures, okay, the main important terminologies I'm giving here. One is the circular pitch. The formula for the circular pitch is pi d by z. D indicates here pitch circle diameter, and the formula for the diametral pitch, it is indicated with capital P. It is z by d, teeth divided by pitch circle diameter. These are the important formulas. Only I'm specifying the important formulas related to the terminology for solving the problems. And if you multiply the circular pitch and diametral pitch, you will get the value as pi. Small p into capital P, that is equal to pi. We will see the remaining terminologies. One is the module. Module is equal to 1 by P, that is reciprocal of diametral pitch, that is d by z. Module is equal to d by z. Z indicates the number of teeth. Therefore, d equal to m into z. Pitch circle diameter is given as module into the number of teeth of the gear. Now we'll see the relation for the center distance of the gear. The center distance can be given by half of the dp plus dg, that is diameter dp by 2 plus dg by 2 will give you the center distance. Replacing the dp with m into zp, dg with m into zg, you will get the relation for center distance, that is m by 2 into zp plus zg. That is the relation for the center distance of a spur gear. If you know the module value and the number of teeth of pinion and gear, we can find out the center distance between these two gears. And the gear ratio formula is speed of the pinion divided by speed of the gear. It is also given as the number of teeth on the gear divided by number of teeth on the pinion. These are the main important formulas related to the terminology. And finally, we will see the standard systems of the gear tooth. We are having three standard systems of the gear tooth. One is the 14.5 degree full depth involute system, and the second one is the 20 degree full depth involute system, and the third one is the 20 degree stuck tooth involute system. You can clearly see the diagrams of all these three types of involute systems. Okay, out of these three types of involute systems, we will generally use the 20 degree full depth involute system, widely recommended by the Bureau of Indian Standards for minimizing the interference between the two gears and also for transferring effective power from pinion to the gear and maintaining the velocity ratio constant without any vibrations. Okay, for the spur gears and for all the gears, for the remaining gears also, we will generally use 20-degree full depth involute system where we are having the addendum as M and addendum as 1.25 times of the M. And the tooth distance here, it is maintained as 1.5708 m from one point, considering the 1 point on one tooth, considering the another point on the another tooth, we are having 1.5708 m. Okay, out of each system is having its own advantages and disadvantages. Okay, if you see here, the 20-degree stub tooth system, we are having smaller addendum and smaller addendum, and whereas here 14.5 degree we are having M and larger addendum. Okay, here I have clearly given here 20-degree full depth involute system with in red color I have indicated. This indicates that this system is widely used. Why? Because I have already given some clarification related to the 20-degree full depth involute system. And here if you see the minimum number of teeth to avoid the interference, it is the minimum number of teeth should be maintained as 17 teeth to avoid the interference, and here you need to maintain the teeth for avoiding the interference. And in all these cases we are following the involute profile teeth curves. And here 20-degree stub tooth system, it is generally used to transmit higher power, and also the strength of the teeth is also very high in this case. But the main disadvantage is in case of 20-degree stub tooth involute system, because of smaller addendum and smaller addendum, the vibrations may likely to occur in this system. Okay, whereas the vibrations and also velocity ratio is maintained constant in case of 20-degree full depth involute system compared to 14.5 degree full depth and 20-degree stub tooth. Okay, we look at some of the advantages of 20-degree pressure angle system, full depth involute system. It reduces the risk of undercutting, it reduces the interference, and here due to the increased pressure angle, the tooth becomes slightly broader at the root, and this makes the tooth stronger and increases the load bearing capacity, and it has greater length of contact. Because of all these advantages, this system is widely used by the Bureau of Indian Standards compared to the remaining two systems.